Hey there, glad you could join me in another channel video. This time I have to present you the first oscilloscope sent by Zeeweii for review. It's the brand new DSO3D12. It's a 3-in-1 2 channels oscilloscope with a signal generator and a multimeter. As I mentioned in previous reviews, those seem to be a trend by these days, and Zeeweii didn't want to lose the train on this one. This video was not sponsored by Zeeweii, but I did receive this unit free of charge for review. So thanks Zeeweii for the cooperation, and thank you, specifically you, that sponsored this channel by using the affiliate access links on the screen or the product link in the description before paying your purchases on AliExpress or Amazon. Your help is really appreciated. Without further ado, let's see the main specs on this one and what was delivered with it in the box. As usual, let's start by seeing what is delivered. It comes in this box, this carton box. Nothing special here. We have only some instructions, nothing really special. So let's see what is delivered inside. Okay, we have the open here. And we start with a set of 2 probes. This is the 6100s. 100 megahertz. We have the usual Zeeweii user manual. The quality is not the best, but it seems to have everything well explained. So yeah, okay, let's move on. Inside we also have a pair of test leads. This is also a multimeter, so it comes with a pair of test leads and the usual USB type A to type C charging cable. And finally, let's take this out of the way. We have here the multimeter dash oscilloscope. So yeah, it's a nice unit. So as first impressions, I have to say this is all plastic, no rubber anywhere, and since this is more to be a desktop device, you don't need really the rubber. It's normally when you have it on the field or something like that. It's portable, but considering the design and everything else, I think this was initially made to be a desktop solution, small size factor. So the keys, those are in rubber, it will not slip, and they have a good feel while pressing it. You feel the click on it. You have also in the front the normal socket for the test leads connection, amperage and voltage and the other tests like hertz and stuff like that. So on the top we have 2 channels, the output for function generator and the square wave, and I think this is the hertz connector or the ground connector. We have also a light that is on when charging and the 5 volts USB Type-C charging port. This seems to be only to allow air to flow like for refreshing this part, and the power button. On the back, nothing special, just this small stand, and nothing on the right or the left. So this is the unit. Let's power this on and start testing. Okay, powering up. You press power button for a while. It boots very quickly. So let's start by seeing the keys. This blue set of keys have the OK auto selection and also auto 2, because we have two channels, and if you use shift with the key and the description on top, you will have a second function. So shift auto 2, also shift and zoom, and if you are not using shift, you have the stop key, the single. This has a single button, very good, and also shift reference to have the reference. On the bottom we have a set of white keys, and we have also AC/DC and AC/DC for channel 2, the channel 1 and channel 2 toggle option. You have also the trigger modes in here with the shift and the menu without the shift. You have these ones on the bottom are the amplitude for channel 1 and amplitude for channel 2. If you use the shift, you have XY modes, and if you use the shift on this one, you have manual. I think it's manual triggering. I will see that ahead on the video. This second row of buttons, you have the ×1 or ×10 selector for channel 1 and also for channel 2 with the shift. Also the button for function generator, and you have the trigger edge, so it should be the slope rising or falling. You have the capture screen button. With the shift you have the view image that was captured, and you have here the 50%, and also for channel 1 and also for channel 2 with shift. The pressing this button. On the if you use shift, you have the full, it will show you the full screen. And you have the trigger selector with shift for channel 1 or channel 2, and without the shift, the select button. On the bottom, the last one is the time base that is obviously common to the two channels. In the screen, we have in this corner the trigger mode, the output of the function generator, and the memory that's positioned in here. We have also the auto for the trigger mode, the rising or falling edge, and the battery charge, the battery status. We have also three values always on the screen: the frequency, the peak-to-peak value, and the voltage average. And in this corner we have the amplitude for channel 1 with the attenuation of the probe. We have the time division, and for channel 2 we have the amplitude and also the attenuation of the probe. In the bottom we have 10 amps unfused current socket. We have also 600 milliamps fused current socket, the common, and the voltage connector for ohms and capacitance and continuity and so on. This is the part for the Okay, in terms of the screen, that's it. We have here the stand as it is. It gives you a very good angle of inclination. Well, before the testing, let's see the operation of the device, the menus and everything else, and I will start with the oscilloscope. So in terms of menu operation, it's pretty simple to work. You just press the menu key like this, and you have this set of menus on the screen. We have the measurements for channel 1, measurements for channel 2, the triggering menu and display, and finally the options, the settings menu. In the settings menu, and let's start with this one since it's already in the bottom. In the settings you can configure several options. The first one is the auto shutdown. To configure that, you just press OK to activate the option, and you use the direction keys to get to the desired menu, like this one, FFT, set to logarithmic, and press, and we have the FFT turn on. So And finally, you have also the calibration here to calibrate the device. The second menu, and to choose each of these options, you will use these keys around the options. So, for example, for channel, the measurements of channel 1, you will press stop. It's the key on the right of the option. You have 3 options already on the screen, those, and also a lot of, I think they are 14, 8, 12, 15 that you can select. And to activate a new option like amp, just press, and as you see, it will show on the screen. That is cycle. Yeah, you got the idea. So the second channel, it will be on this color, this pink color, and you just press single. For triggering options, you will press the AC/DC button, that's on the right. You have several options, the triggering modes, the normal, well, you have everything in here. And finally, the display. You can have the persistence of the signal with 1 second or infinity, if the roll is active or not, and the high rate, right now it's on. You can also select the brightness like this to increase the brightness of the screen or decrease. And basically, as you can see, this is really basic. You don't need anything special to operate this. So yeah, in terms of menu, that's it. One of the things I didn't show before was this icon here. It informs you which channel you are working with in terms of keys and everything else. So right now the yellow, it's activated. If you come here, now it's the channel number 2, the pink one. Okay, so while using the keys, the channel that is being controlled is this one. To activate or deactivate channel 2, you press shift and the channel selector key. Okay, we are again with channel 2. Let's go to menu. I forgot to show you something. While you are in this menu, if you press S for a while, you change the color scheme for the measurements. Let's try again. Right now it's black on white, gray on black, more like that, without background, and this is the normal one. Okay, we have 4 options, I think. Yeah, let's move to this one. I like this one. Okay, and I think that's it. Nothing special here. I will now show you how the function generator works. Okay, so I have my setup already in place. I have my Owen XDG2100 configured with 100 kHz 1 volt VPP. I will initiate the signal. Okay, and let's do a auto. Okay, it does a auto pretty fast. As you can see, it detects the 100 kilohertz, and also the peak to peak is over 714 to 20 millivolts. So until now, pretty nice. Let's start upgrading the bandwidth. This is a 120 megahertz oscilloscope. So I will jump right into 25 megahertz. 25 megahertz. Okay, let's do a auto. We are at 50 nanoseconds and we are able to go up to 5 nanoseconds. It is a nice signal, stable, so pretty fine with me. We have 25 megahertz detected. The signal is still over 700 millivolts, 740 to 20. So let's double this, 50 megahertz. Okay, it's at 50 megahertz. We cannot increase anymore the signal in terms of time division. We have a peak-to-peak of 930 millivolts. It's a bit weird because it's higher than the 25 megahertz, but let's move on to 75 megahertz. Okay, it dropped a little again. It detects the 75 megahertz. It seems that a little flicker starts to appear, but really nothing serious. This is totally fine. And let's take this to 100 megahertz. This is the maximum of my function generator. I cannot pump this anymore. And okay, now we see a big drop. We have 100 megahertz, but the peak-to-peak it's at okay, let's be fine and say that is 500 millivolts. Now that's the time that I will start dropping the bandwidth until we find here the voltage over 700 millivolts. Let me just move this, and okay, I'm decreasing the bandwidth, something like this. Yeah, something like 82 megahertz probably is the real bandwidth. Not bad, even so. Even if you take this to 100 megahertz, let's do it again. The signal, let's do auto. This is curious. With auto, we have a 990 millivolts. So is this adjusted electronically or? Okay, let's move again to 50, just to be sure. Auto. Okay, 900. Maybe it was me. 75. I didn't do auto while moving it. Look, it's 800. But if I do an auto, let's increase this. Okay, 850 again. This is 75 megahertz. Again, let's move to 100. 100, it drops to 500 millivolts, but if we do an auto, he readjusts. No, it's at 500. Yeah, even with auto. Now it's even lower. Okay, so again, let's move this slowly to the desired bandwidth. I think we can go up to 82 megahertz. Yeah, 82, 83. Again, auto. '82, '83. I will say it's the bandwidth of this device. Okay, even so, seems good. It will be much better if it go up to the 100 or 120. I have to get a function generator with higher bandwidth, but they are pretty expensive, so yeah. Okay, in terms of bandwidth, it's tested. My function generator only accepts ramp at 3 megahertz. Let's try again, 3 megahertz with square wave. Yeah. This is the Okay, we have noise and we have the heart. Let me see if I can draw that in the screen. So at 500 kilohertz, it seems that we are able to see the heart. It's always nice when we can, the oscilloscope has the capacity to draw this figure. Okay, very nice. I think that's it for now. Let's move on. For the function generator, I will also first try to calibrate the probe so you can see how it's done. Just connect here on the top. Let me see if I can get it to this one. This is the commons, so it should connect in here. It's a hard spring, that one. And we put the channel 1 in here. So right now it's outputting, as you can see, a sine wave. It doesn't seem too bad. We can do an auto. Okay, it's fixed. Seems already pretty good, but let's start by compensating the probe. For that, we will activate the function generator. And if you press the single button in here, as you can see, it will transform this in 1 kHz signal. And we just need to change this to square wave. So let's use the time division button like this. And as you can see, you can change the waveforms with this button to the left or right. Okay, let's go again to the square wave. Now it's outputting a square wave, and we can take the generator out of the screen. If this little icon on the top is yellow, means that the function generator is outputting, and it can work while you are analyzing the signals with 1 or 2 probes. To turn it on or off, you just press stop. Now it's off, and now it's on. Pretty easy. To leave this menu, you just press OK, or again the generator option. As we can see, the signal, oops, not this one, this one, let's increase a bit, and yeah, so the signal, it's pretty good. I don't think that we need to compensate the probe, but if you need and don't know how to do it, just use this screwdriver and this hole in here and rotate. Okay, it seems that this key will not go back. I have another one here that I will use. This is from the Zeeweii oscilloscope, and yeah, the difference, it's quite big. Yeah, you can use a normal screwdriver. This one has metal in the end. It makes all the difference, because while you start rotating, sometimes this will be damaged. One thing that I would like to mention is that the rings that are delivered really match the colors of the channels. You have pink and yellow. You might think this is a silly thing to mention, but most of the times those rings do not match the colors of the channel. So it's pretty stupid, I don't know why, but Zeeweii make sure that it will deliver the correct ring color. So we have this properly compensated. Let's see what we can do with the function generator. In terms of function generator, you have 4 settings. It's pretty easy to use. So you have the bandwidth, output bandwidth here, the unit that you will use, hertz, kilohertz or megahertz, the duty cycle. This is valid only in some options, and obviously the waveform output. This is just an indicator if the output is on or off. In terms of waveforms, as I showed you before, you can change using the time division button, and I think you have 6 or 7 waveforms. Okay, let me see the noise, and back to the sine wave. In terms of changing this, it's pretty easy to change, but it will not affect much the majority of the waveforms. Let's see, it will change on the square wave as it should. Also, yeah, it will affect only a few of them. Yeah. To change the values, you just press up and down, okay, and left and right to change the position. In this one, you can go following the normal, always pressing in the minor value, but you can also change to the upper value to change the values, okay. Hertz and kilohertz up and down. And basically that's it. Don't forget to turn it on or off in the stop button. So now it's playground time. I have already in the screen the XY mode. To activate the XY mode, you press Shift and MV up. As you can see, you have two channels connected right now to my oscilloscope. Both are with 100 kilohertz, peak to peak to 1 volt, or it should be like that. Let me do an auto. Yeah, something around that. So let's activate again the XY mode. We have a perfect circle, and I will start by putting this circle moving. Okay, let's start slowly. Yeah, and right now we have a nice rotation. Okay, so what can we do next? Let's start by increasing some curves. Yeah, let's keep this one, and coming here to the Y, yeah, we have some rotating figures. In terms of rendering, it seems to be very good. We don't see flicker. It's nicely drawn. I think I'm pretty happy with this. Okay, let's do auto again. Okay. There is the XY mode working pretty nice. I think I will now try the FFT. Okay, now is FFT time. For that, let's activate the FFT here on settings, and oops, let's move the FFT to logarithmic and press OK. As you can see, you already have something on the screen. Let's take the menu out of the screen. Yeah, this is only noise. I will start playing some music here on my PC. First I will just put on the speakers. Is this one. So let's pass it to the cable that I have connected to my PC output. And as you can see, here it is. And you have the FFT also on the screen. And let me change this to linear. Okay. So in linear mode, it's like this. Let's do auto again. You can see here the signal changing. And also we have another one, a cool one that we normally see on the stereo equipment. That is, let me take it out, the spectrum analyzer with the bars. So yeah, this is a, a nice feature. They could have the scale on the sides also. It will be cool to have it. But yeah, this is the FFT feature on this oscilloscope. One of the things that I still have to show you is the cursors function. As everything else in this oscilloscope, it's pretty easy to use. Just press Shift and S for the vertical cursors, and Shift and NS for horizontal cursors. When you have the cursors on the screen, just use the left and right to move the vertical left cursor, okay, like this, and up and down to move the vertical horizontal cursor. So to move the right and bottom cursors, you will press Shift and then use the same keys, but this time you will be able to move the right cursor and the right vertical cursor. You have the calculated values on this square, so nothing real major, really easy to use, okay? And you can use only one, for example. Let me just, for example, only the vertical cursors or only the horizontal ones. So this is the cursors function on this DSO3D12. If you want to save the image that is on the screen, it's pretty easy. Just press the save key like this. He will tell you that the save is done, and then you just need to go with the Shift, save again, and you will be able to see the saved image on your screen. If you want to see one of the image that the cursor is, just press Auto or OK. In this case, it's the OK key. It will show you the image. You can use the left and right to browse through the saved image, okay? And if you want to go back to the menu, just press again OK key and you are able to go to that menu. If you want to delete one of these images, like this one, you have here three keys. One of them is for leaving, the other is for deleting, and the other one, I don't know what it is, it's for seeing the image. So just press delete and it will not even ask you if you want to delete. It just delete the image. And for leaving, just press here on the DMM and you are able to go back to the main screen. Another function that we have here is the zoom function. For that, you just press Shift and stop key. It has zoom on top of it, and you are able to see all the memory of the saved signal. So it's pretty easy to use. Just go left or right through the signal. It's a little bit weird because if the direction is that way, the signal shown is on the other side, like this. But yeah, okay, nothing special, just use it. You have the complete image in here and you are able to move it like this. If you want to move in a slower pace, just press Shift and the movement will be slower than the normal. Press Shift again and you are back to the normal velocity. This happens also in the main screen. For example, if let's take the zoom out, let's do auto, okay, and we are able to navigate with the image, okay, and if you press Shift, it will go slower than normal. For me, it is best to go faster. Okay, that's it in terms of zoom. Another feature that I want to show you is the reference. For that, you just go and press Shift and then the single key that has reference on top of it. Okay, and you can move your your waveform to another side and you will have the reference of that waveform on the screen. Yeah, if you want to know what is the waveform in a certain moment, you can press the reference and it will store the waveform and you can do whatever you want with the current waveform and the other one will be on the screen. So to take this out of the screen, just press Shift again and single, and that's it. Okay, to operate the multimeter, we have two ways of doing it. The first one is just activate the DMM. It will show you the voltage in there. And you can select the different options of the multimeter by using this menu that appears when pressing select. And you select whatever you want to use. Please notice that he will indicate in which sockets you should connect your test leads. So, for example, milliamps, amps, you will have to connect here on the unfused socket. If you pass 2 milliamps, it will change to this socket, and so on. Okay. This is a pretty cool system. You have everything in here. You have several options to use, but it's not the perfect screen to use. Let's use this auto. So right now you have overload, but you can also select this in full screen mode, and for that you just press Shift, DMM, and you have a working multimeter if you don't want to be working with the oscilloscope at the same time. The cool part is that you can be working with the oscilloscope at the same time, or you can only use this as oscilloscope or as a multimeter. So as a multimeter, it's pretty nice, I must say. It has a large screen, big letters, pretty easy to identify. So let's test this. I have here my setup in place, so let's start. Okay, so the test leads that are included are these ones. I will show this first. The cable is plastic, but it's very flexible, as you can see. We have these caps on the end, okay, and also in the plugs we have these small caps to protect. Oops. Okay, let's connect it. We have to select here in the menu alternate voltage or AC, okay, and now we will be very careful to test the mains voltage. So first the common and then the live. Okay, it's calculating 236. So the other day on another multimeter test I had 240 to 41 volts on main. So I was doubting this value and I went to grab my Unity, and as you can see on the Unity I have the voltage of 237 volts. So basically the Zeeweii is measuring correctly and there is nothing wrong with the measurement. Okay, so I have my setup in place. On the left we have the Zeeweii DSO3D12. On the top right we have my DC voltage calibrator, and on the bottom right we have my Siglent SDM3045X multimeter. What we will do now is start testing the DC voltage. I will start with 1 volt. Okay, we have a little difference between the two of them. Okay, let's move to 2 volts. Yeah, still a little difference, a little bit over. This one is normally more accurate, and you can see it on the previous tests. So 3 volts, nothing really serious to be honest, but yeah. 4 volts, I'll let you decide. 5 volts, 6 volts, 7 volts, 8 volts, and finally we have 9 volts. Okay, so pretty near. I'm okay with these values. Let's move to the second one. We are entering in the millivolt range. So let's start with 10 millivolts. 100 millivolts, 200, 300, and spot on the Zeeweii. 400 millivolts, 500, 600, 700, 800, 900, and it is a little over the 900 millivolts, but pretty near. Okay, we are back to 0. Let's move this to the millivolts range. Select and continuous millivolts. Okay. We are in the millivolts range right now. Let's move this to 100 millivolts and let's see what we get. 999. Okay. 200. 300. 400, 500. I think this is really almost spot on, and this can go up to 600 millivolts. So it is right now on the red. We can move again to the volt range. Let's see. Okay, 601 and 700, 800, 900. It is a little over the range, but okay, let's put it back again on millivolts range, because we are going to the 10 millivolts. Okay, 20, 30, 40, 50. In this one it has a little gap, 70, 80, 90, and back to 0. Okay, moving to 1 millivolt, 2 millivolts, 3, 4, 5, 6, 7, 8, 9, 10. 10 is back to 0. Okay, I will not go under 1 millivolt. It has small gaps, but I think that is pretty near to be spot on. Okay, so okay, from my part that's it. Let's try the millivolt reference board. Okay, if you normally see my channel and the videos I do, you know that by this time this is a little bit redundant. This is my millivolt voltage reference board, but this board has a little issue that normally I use to test the capacity of these devices to see a glitch that I have on this board. This board was made on PCBWay, so let's hear about it. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. Now that we all know how to make a cool board like this, let's start testing. The first one is 10 millivolts. Let's see what we get. Okay, 10.52 and 10.58 on the Siglant, not bad. The second one is 25 millivolts, 25.1 and 25.21. Okay, pretty near. The third one is 50 millivolts, 49.97 and 50.17. Okay, 100 millivolts. Okay, spot on. 250, I have to use like this, so 250, 256.7 and 256.82. Okay, nice. 500 millivolts, and we are really getting near the limit of this device in terms of millivolts. Already has the red sign, so but 501.7 and 501.84. So right now I have to change this to volts. Okay, and let's start with 1 volt. We are getting 994 millivolts on the Zeeweii and 989, 990 on the Siglent, because the 96 rounded, it's 990. Okay, and 2.5 volts. Okay, 2.501 on Zeeweii and 2.4909 on Siglent. Okay, nice. And this is the one that normally the multimeters can't give the correct value, and Zeeweii is there. 4.1699, 4.7, and Siglent's 4.6806. So this one, pretty cool. It is able to give this value. Okay, moving on. In terms of milliamps, I have here my FNIRSI SG004A to test. It's a pretty simple setup. Just connect to the output, and let's start by turning the output on. So we have 1 milliamp. It has a difference of 0.04, and if you notice, it comes from the beginning of the count. So I don't really know where this comes from. Maybe the cable, something like that. Let's start with 1 milliamp, 2, 3, 4, 5, 6. If you notice, it's pretty spot on. If you discount the initial value, residual value, 7, 8, 9, and 10. Okay, 10.02, almost spot on. Let's take it to 15. Okay, very nice. And 20. Okay, almost spot on. And for last, we have 24. It's the maximum of the milliampage output of this device. This is a process calibrator, so that's it. Okay, in terms of milliamps, that's what we have. Let's move on. Now let's see in terms of resistance what we have. Let's start with this one. It's the 10 ohms. I forgot to change. We have to change here this to resistance. Okay, awesome. Let's start again. So we have 10 ohms, 10.5, pretty nice. We have 10.03, 100.03, 0.4, not bad. 1 kilo ohm, 1.0003, so 1 kilo ohm, spot on. 9.995 kilo ohms, 9.97, yeah. And in terms, you have here 100 kilo ohms, I think. Yes, 99.9. Okay, pretty near. For capacitance, we have to change it again. Let's move here to capacitance. The first value that I have here is 102 picofarads, but probably it will not be able to read it because it's out of range in terms of values that are supported and described in the user manual. So yeah, okay with this one. The second is 1.02 nanofarads, 1.09, okay. The third is 10.4 nanofarads, 10.5, pretty good. This one is 98.7, I think, 99.7, okay, acceptable. This one is 929, it is written here, but I'm not getting this lately on my test, so let's see what we have in here. 893, it's more close with the values that I have in the previous multimeter reviews. I have to retire this board and I don't have one yet to substitute. And the last one is 10 microfarads, so we have here 10.32. Okay, so I have here my diodes to test. Let's change these to diodes. pretty easy. And let's start testing these ones. The first one I have here, it's a diode. Okay, so 0.61 volts, 610 millivolts. That's correct. We have now this one, it's a small LED. As you can see, it shows the light when measuring, and 1.7037, that's correct also. The second one is one of those big ones, LEDs. No one uses this anymore, but 1.766, also good. And the last one, I think it's 2 volts. Let's try. Also, we can see here the light, 2.770. This is also good. Only missing to check the continuity. Let's see it. It's not a perfect contact. Sometimes it seems that he misses, but it's not bad. Oh, look. It misses a bit here. It's not perfect, but it's usable. Yeah. And it takes about 1 second, 1 to 2 seconds to update the screen. Okay, continuity checked. Let's move on. So it's teardown time. Okay, so here we have it. That's a lot going on in here. I will have to zoom in to check this out. Okay, in this corner we have 1 amp fuse, and on top of that on the sub-miniature relay, I believe, yeah, it's a signal relay. It's this one, AFD 3-4, and on the right side you have the Everlight, I think, Everlight Electronics model 817 photocoupler. We have here this one. I found the manufacturer, but I was not able to find this model. It's the Unisound US665P31. I'm reading this upside down, so I was not able to find that. Also, we have here a controller that is scratch or laser burned, and another one in here. There is a lot of these op-amps. Yeah, this one is a OP1612, Sound Plus High Performance Bipolar Input Audio Operational Amplifier op-amp. Okay, we have a lot of this in these boards, and not only this one, but yeah, you see it here, the 74HC595D, and this one is just a shift register with output latches. You have 8-bit serial in, serial or parallel out with 3 states, and we have a lot of them, not in here. I will show you in a bit where they are. I have a lot of these ones, and also we have here a processor. This is from the Winner Micro Electronics. It's a 32-bit CPU with the built-in WART, GPIO, SPI, STDO, and so on. So it's pretty nice that nowadays we can find some English documentation for those processors. There are a lot of devices that have them. And we have here these shielded parts. I already unsoldered. Let's take this out and see what we have in here. So in here we have 2 channels, obviously, and for both of them we have the signal relays, and we have also those 74HC4051. Those are analog multiplexer and demultiplexers. So in here we also have the OPA 1612 or the OPA 1612, and also another one in here that we already talked about it. And in the bottom we have also this 74HC595D. Again, these are shift registers. So, and I think there is also, here it is, the DAC, I believe. It's also scratched, so you don't know what is going on in here. And you have this OPA 2673. And this one seems to be a dual high output current op-amp with active offline control. That's what the datasheet says. Obviously you have here the part with the sockets for the multimeter, and the motherboard seems very well constructed. It is one of the, in terms of these small devices, that I've seen with a shielded components section. Below this heatsink you should have the charging controller. It's normally near here, the socket for the battery. And yeah, basically that's it. Let me unzoom a bit so you can have a close look of all the board. Okay, here you have it. You can see now perfectly delimited the zone where we have the shielded component. So now let me just close this and do the conclusion. To wrap this up, and I have a lot to talk about, but as I've been doing lately, let's start with the price. It's being sold in AliExpress Zeeweii official store for 97 euros or something like, to today's exchange rate, $103. But you can find it even at lower prices searching on AliExpress. I noticed that some of the brands that release these oscilloscope plus multimeter devices, sometimes, not all of them, but sometimes they release these devices with lower bandwidth. Something that didn't happen with this product. You still get 120 MHz signal generated and the multimeter, so in terms of price it is okay. Especially if you consider that the DSO3D12G, a big time success and one of my favorite small oscilloscopes, is sold around 78 euros or $83, so you'll get the complete package for extra 19 euros. The format is a bit odd, considering that we normally see these oscilloscope plus multimeter devices where you have the normal multimeter design with the bonus oscilloscope functionality. But in my opinion, it is a bit more aimed to be a desktop device. Something like a miniware product made in small size but with big features. Even these small corner protection thingies, imitation like the desktop devices have, give you a feeling of a desktop equipment. But with the size and the battery is perfectly fine to use as portable oscilloscope or multimeter or even signal generator. The multimeter, as it should be, it is accurate and the measurements are perfectly within the error margins values. The bandwidth is also within the expected, but there is always some doubts about the real bandwidth of these devices, so I will not dig too much into this, but I can say that for me, in my opinion, this is a nice little fellow. I do like the menu system, even if the graphics can have a bit more work on it to have better look, yeah, but this is all fixable with a new firmware, so no biggie here if they release this firmware. The keyboard layout is good, easy to work and everything makes sense. It's intuitive, so you can kind of start working with it without much fuss. The 3.2 inches screen is really a plus. For a small device, a bigger screen helps to see the values on the screen. And this size is a plus considering the competition that normally uses a 2.8 inches screen. I would prefer to see the function generator output, this one, with a normal BNC plug or even the MCX ones if you want to save the space. But this little thingy here that is normal to, or is normally used to calibrate the probe, is kind of short for the signal generator output. And to be honest, this is the only thing that I have to point out in this device. All things considered, I think this is another win for Zeeweii. They deserve some love because the products are really nice and packed with features for a reasonable price. So kudos for them. If the DSO3D12 is the device you have been searching for and you are considering buying one, please don't forget to use the affiliate access links on the screen before paying, or just go directly by using the product link in the description. Become a channel sponsor just by using these links without any cost to you. Your help is really appreciated. If this video was useful to you in anyway, please help me spread the love and slap that like button. If you haven't subscribed yet, consider doing it. Every week I receive new equipment to review. That's all I have for you today. Thank you for watching until the end and let's meet again in my next video. Cheers!